Hello everyone, my name is Martin and today I will discuss an insightful study titled Beyond Full Fine-Tuning, Harnessing the Power of LoRa for Multitask Instruction Tuning, conducted by Chunlik Sin and their team. This work explores the capabilities of low-rank adaptation, or LoRa, and compares it to full fine-tuning. LoRa works by freezing the pre-trained weights and adding two trainable matrices, which are defined by their rank and alpha, and which effectively lowers the number of trainable parameters of a model. The researchers used supernatural instruction dataset with over 750 tasks, and this dataset contains three main parts: task definition, positive and negative examples. The researchers further split this dataset into smaller subsets containing only 100, 250, 500 and all tasks. For each task they choose 100 examples. They trained Llama model with 7 billion parameters, and they tried LoRa settings with rank from 4 to 4096, and all the fine-tuning was done on NVIDIA A100 with 80 GB VRAM. There are three main findings in this study. The first one is that LoRa can achieve remarkable performance in high-resource multitask settings. Up to now, it was believed that LoRa is effective only for low-resource settings with small ranks. The second key finding is that LoRa can bring implicit regularization to training, and this is observed with rank higher or equal to 1024. And the third main finding is that when the LoRa has sufficient learning capacity, it can learn the semantics of the task instructions and thereby enhance the performance on unseen tasks. The researchers studied the generalization in instruction tuning. For that purpose, they measured the intra-task generalization when the model was tested on the same task it was trained on, and in the inter-task test it was tested on unseen tasks. Here we can see comparison of intra-task and inter-task tests. Intra-task test shows how well the model performs on tasks it was trained on, and inter-task test tests how well the model performs on different tasks than it was trained on. The dashed lines shows the models that are full fine-tuned, and the solid lines represents LoRa fine-tuned models. The color of the lines shows the number of tasks it was fine-tuned on. The intra-task test shows that the LoRa reaches intra-task performance of fully fine-tuned model with ranks around 2048 and 4096, so the highest ranks it was tested in this paper. On the other hand, the inter-task test shows that LoRa starts to outperform a fully fine-tuned model, also with high ranks, but we have to keep in mind that the model contains less trainable parameters when fine-tuned with LoRa than fully fine-tuned model. This table depicts the exact match and Rouge L scores of LoRa and full fine-tuned models on inter-task dataset. Here we can see that with the rising rank, the number of trainable parameters also rise, but it's still quite low compared to the number of trainable parameters of full fine-tuned model. And we can also see that with the rising rank, the LoRa fine-tuned scores starts to outperform the ones of full fine-tuned models. LoRa has a problem when with low ranks it learns to follow the instructions so it can answer in correct format, which causes that the percentage of out-of-options outputs from LoRa is significantly lower than that of full fine-tuning on intertask. But these answers are often incorrect with low-rank LoRa, which means it didn't learn the task semantics. This is also visible on specific tasks like word analogy, dialogue act recognition, and data-to-text, where red responses of LoRa model has the right format but are incorrect. This improves with increased model capacity, as for example, here LoRa with rank 2048 answers correctly. The researchers found different thresholds of rank sizes when the model started to understand the task, not only follow the instructions. The researchers compared LoRa with ranks 16 and 2048 and full fine-tuning on constant data size. The results are depicted in columns and the values are averages from multiple measurements. The first row measures the intratask performance, and the finding here is that the learning capacity can significantly impact the memorization capabilities of large language models. When the dataset size is fixed and the number of tasks increases, the language model memory capacity is crucial for performance on seen tasks. So, with increase of learnable parameters, we can see an improvement in intratask generalization capabilities. In the lower row, we can see the results for inter-task tests, and the researchers found out that the relationship between learning capacity and task diversity has intricate effects on the generalization performance of large language models. Larger learning capacity doesn't necessarily lead to stronger generalization performance. Performance of full fine-tuning lags behind that of LoRa with a rank of 2048, which only possesses 24% of the learnable parameters of full fine-tuning. The reason why LoRa outperforms the full fine-tuning is that it introduces an implicit regularization, and this regularization improves the generalization performance of the language model. To summarize this article, I would say that the main message from the researchers is that when you want to fine-tune a model for multiple tasks, you should consider fine-tuning it with LoRa and set it to higher ranks. And when the model didn't learn the task semantics, you should also consider even higher ranks. I also repeat here the key findings of this study. My opinion about this article is that it is well written. One downside is that they conducted experiments only on one model, which is the Llama 7B, and didn't compare it to multiple models. Another downside is that they didn't fully explore the limitations of low-rank adaptations due to low resources. On the other side, the results of the study are interesting and worth to study further. Thank you for your attention. Don't hesitate to leave questions in the comment section. Bye.